Hi, this is Ms. Reese, and we're going over the Unit 6 review, Edpuzzle. So I'll be doing some of the questions, and then you'll be trying some on your own. So in the first problem, we are looking for the sum. So if you've noticed here, we're adding these two things together. And if we're adding them, the signs of all of our terms, they're not going to change. So we don't need to rewrite anything. Then what we're doing is just saying, okay, what are our like terms? So we have 1, that would be a like term with this 2 here. We have the n squared, 2n squared, that would be a like term with this 2n squared. And then our n to the 4th powers, those are also like terms. So now we just need to rewrite it where we're combining them. Okay, so we'll go ahead and combine the 1 and the 2, that would become 3. And I'm going to rewrite this in what I call descending order. You'll see it here. So I'm actually going to do the exponent of the 4th power first. Let's do these first. Our highest exponent comes first. So we have 5 and 3 added together. That is 8n to the 4th. Okay, so all you're doing is combining the coefficients. And then our squared terms would be next. So that we have 2n squared, and then we have 1 to that. And technically it's okay if they can go in any order, but for all the questions where you see answer options, you're going to see them in what we call descending order. So the largest exponent number first. And so you're going to go ahead and try answering question number 2. And you'll notice here all of the answer options are in descending order, the largest exponent being first. Okay, on question 3 here, we are finding the difference between these two. So I'm actually going to go ahead and rewrite this one and distribute the negative. So we get 3n minus 6n to the 4th plus 3. And then really everything in this parentheses is being subtracted. So we're really subtracting 4n squared. We are subtracting the 7n to the 4th. And we're subtracting the 7. So essentially what this does, this negative is distributed to each term. So it essentially changes the sign of each term. So for example, if one of these terms was negative, it would turn to a positive. And if it's positive, it will go negative, vice versa. So now all you need to do is go ahead and combine like terms. I'm going to look for my highest exponent first. That would be the 4th powers, so these two here. Negative 7n to the 4th and negative 6n to the 4th. And then we have our n squared term that is all by itself. It has nothing to combine with it, so I'm not going to highlight it. Our 3n term that also has nothing to combine with it, but this one does here. These two will combine. So then we can rewrite this. And oops, this will be, we'll do the n to the 4th power first. So negative 6. And a negative 7 combined would be negative 13. And then our next term would be the negative 4n squared. Then we would have a 3n. And then we're going to combine the 3 and the negative 7. So 3 minus 7 is negative 4. That is in descending order. Okay, so you are going to answer question 4. You're first going to rewrite it without parentheses by distributing the negative, which changes the sign of everything. And then combine like terms. Okay, on the next question, we are finding the product, which means this 5x is multiplying to everything inside the parentheses. So 5, we multiply the coefficient. So 5 times 2, that's 10. We have an x multiplying by an x squared. So really what that is, it's x times x squared, which is just x times x times x. So really there's 3 of them altogether. So 10x to the 3rd. And then we have a 5 multiplying to a negative 5x, so that's, or negative x, that's negative 5. We have 2 x's then, so x squared, and then 5x times 3. 5 times 3 is 15. Okay, so go ahead and try question number 6. Okay, for the next question, you're going to create a box for this so that we don't forget to distribute all the terms to each other. So we've got a 2 by 2 box here. So we've got 3n plus 3, that'll go along one of the sides, and then the 7n plus 8, that'll go along one of the sides. Okay, so now we just go ahead and multiply into each of these boxes and then combine like terms. So 7 times 3 is 21, n times n is n squared, 7 times 3 is 21 again with an n on it. 3 times 8 is 24, and 8 times 3 is 24 as well. And then all we need to do is combine like terms. So 21n squared has nothing to combine with it. There's no other squared terms. We have 21 and 24. Those are going to add to 45. Plus 24. Okay, so on this question here, you're going to create that box, the rectangle, put these pieces along the sides, multiply everything, and then combine like terms. Okay, on question 9, anytime you have a term squared, that really means that term is being multiplied by itself. That's what it means to square something, multiply it by itself. So this really is n plus 7 multiplied with n plus 7. So you are still creating that 2 by 2 box for that. So we have an n and a plus 7, n plus 7. So we're multiplying n with n. That would give us n squared. 7 times n, 7n, 7 times n, 7n, and 7 times 7. That's going to be 49. So now when I combine all my like terms, we have an n squared plus 7 and 7, going to be 14, and 49. Okay, now you're going to go ahead and try question number 10. And we call those perfect squares. Now this one is called a difference of squares. So we're multiplying two terms by two terms still. So we have 2k minus 4, and we're multiplying that with 2k plus 4. So 2 times 2 is 4, k times k, that's k squared. Negative 4 times 2k is negative 8k. 2 times 4 is positive 8k. And negative 4 times positive 4 is negative 16. So now if we combine like terms, when we add 8 and negative 8, that becomes 0. So we're just left with 4k squared minus the 16 here. Okay, go ahead and try question number 12. Okay, on 13, we are looking for greatest common factors between each of these. So first thing, if we don't know the greatest common factor, but we do know that one number that goes into them, I would say, okay, well, I don't know the greatest common factor here, but I know 2 goes into each of these. So I'm just going to start dividing all of these by 2's. Let me make this a little smaller. And I'm going to open up the Desmos calculator too. And that's what I would recommend you to do as well. It's a Desmos Scientific. Or you can just use any calculator that you have as well. Okay, so we're looking for greatest common factor. I don't know what the greatest common factor is quite yet. Oops. I'm gonna move my face up to the top. There we go. Okay, so first thing we're gonna do, 156. Move that as well. Okay, so we're gonna take 156, we're gonna divide that by 2. And that's gonna be 78. Let's do all of these. Let's do 144. divided by 2. And then our last one, let's do 228 divided by 2. Okay, so I'm dividing each of these by 2s, and I'm going to put the number that I get for that. So that's going to be 78. I'm just going to do the number part to this. And then we've got a 72, and then we've got a 114. So now I say to myself, okay, guess what? I know 2 goes into each of these. So I'm going to take out another 2. So let's do 78 divided by 2. Let me change this to a 78. Let's do 72 divided by 2, and let's do 114 divided by 2. All right, so then we get 39, we get 36, and we get 57. Now the only thing that I think might go into all of these is 3. Let's check. So 39 divided by 3. I know 36 is divisible by 3, and I know 57 is also divisible by 3. Okay, so I know 3 goes into them. So you're basically just looking for even small numbers that go into all of them, and then I would get the 13 here, I get a 12 here, and I get a 19. So in terms of greatest common factor, it would be 2 times 2, which is 4, 4 times 3, which is 12. So our greatest common factor for the numbers is 12. Okay, and then if I look at my variables, I have no variables in the first term, 2, and then 5 in the last term. Okay, so we're going to rewrite this in factored form. We factored out the GCF. And you don't have to use my strategy here. You could also just know what the greatest common factor is. That's fine. But we're going to end up with 12. 12 divided, or 156 rather, divided by 12. Now that I use this method, it's going to be 13. Just that last number at the bottom there. Okay, and then we could do 144 divided by this number here, 12, is going to be 12. That's the number that's left here, 12r squared. And then negative 228 divided by the 12 is going to be this 19, so negative 19r to the 5th. Okay. Now I'm going to have you go ahead and try question number 14 on your own. Find the greatest common factor and then rewrite it in factored form. Okay, question number 15. First thing we might want to do is look for numbers that go into each of these. I know 2 goes into each of them. I always like to start with 2s, with my even numbers. So 16 divided by 2 is 8. 12 divided by 2 is 6. 20 divided by 2 is 10. Oh, good. 2 goes into both of these again. And I get a 4. 2 goes into 6 3 times and into 10 5 times. And then now there's no common factor. So I know my greatest common factor is 2 multiplied with 2. And so 2 times 2 is 4. And then I have to say, okay, well, my greatest common factor, there's actually variables in common with these. Well, I have 1, 2, 3, 4, 5, 6, 7, 8 n's in the first term. I have 1, 2, 3, 4, 5, 6, 7 n's in the second term, and then 5, 1, 2, 3, 4, 5 n's in the third term. So I'm looking for the greatest number that they have in common. So they've all got 1 n in common, 2 n's in common, 3, they've got 5 sets of n's in common essentially. So like here's the 1, here's the 2, 3, 4, and 5 n's in common. So in terms of my GCF, it is 4n to the 5th power. Now when I'm trying to rewrite these, so I know my outside piece is going to be 4n to the 5th. Well, now that I've set it up like this, I know 16 divided by the 4 is going to be 4. And then I have 3 n's left up here that didn't get circled. So n to the 3rd. Or if you can just check this back and add them, and then you get 8 again. Okay, 12 divided by 4, I know that's going to be this number here, 3. And it looks like we have 2 n's left, n squared. And then 20 divided by 4, that's going to be this number here, the 5. And then we have no n's left over here, so just 5. All right, try question number 16. Okay, and the last set of questions, we're going to be factoring completely. Move myself over there. So to factor these completely, we are going to use that box and diamond again. So for each of these, you're going to do a box. And we're going to put the first term in the first box, the last term in the last box. So first box being top left here. First term goes in the first box, n squared. Last term, 27, goes in our last box. We now create a diamond here. We multiply these two, put them to the top of the diamond. And then this middle number here goes at the bottom of the diamond, 12n. Now what we're looking for is numbers that multiply to make 27. But so I'm just going to write out numbers that multiply to make 27. I always know that 1 and whatever that number is, got to make that number when multiplied. 2 does not go into it, but 3 does. 3 and 9 goes into that. 4 doesn't, 5, 6 doesn't, 7, 8, 9. So I think those are it in terms of my factors, 27. So then I say, okay, which of these options is going to add to 12? So I need a positive 3n and a positive 9n. Because remember, the top is our product and the bottom is the sum, what we add. 9 plus 3 is 12. So then I can just fill in these pieces here, 9n and 3n. And then to find the dimensions of the rectangle outside here, now a common factor between these two, well, all these have in common is an n. That's the greatest common factor. All these two have in common is an n. So this is almost like reverse of multiplying. And then n is multiplied with a 9 to make 9n. N is multiplied with a 3 to make 3n. And then we could just, our factors are going to look like this. So we're going to have n plus 9 is one of the factors, and n plus 3 is another factor. And those can be in any order. You could put either one first. Okay, so you're going to try question 18 this time, and instead of a multiple choice question, you're going to put your solution, type your solution, and you should have your 2 sets of parentheses with factors that look like this. Obviously different numbers. Okay, let's try another one together. Again, first term in the first box, last term in the last box. So first term n squared, last term negative 54. We're going to multiply those, put it to the top of the diamond. And then we're going to put the middle term to the bottom of the diamond. Okay, we're not looking for numbers that multiply to 54. So remember 1 and 27, I'm sorry, 1 and 54 are going to multiply to make 54. That always works. What is it? I think it's 2 and 27. Divided by 2. Yeah, 2 and 27. And you can use a calculator for these. 54 divided by 3. 3 and 18 is also works. I don't want to move on to the box here. Let's do 54 divided by 4. That doesn't work. 54 divided by 6 works. 6 and 9. And I think that's it for factors of 54. 7 doesn't go in. 8 doesn't go in. You can just keep dividing it by things. Nothing else is going to work there. Okay, so that's it for factors. Now we just need a combination of numbers that multiply to a negative but add up to that positive number on the bottom. So the only way to multiply to a negative is with one positive and one negative. Only way to multiply to a negative. Okay, so then we say, okay, which combination of numbers, if one of these is positive and one of them is negative, essentially are going to subtract to make 3. So the only thing I can get when I subtract these is a negative 53 or positive 53. That's not going to work. These factors don't work. These two numbers, when I subtract them, I could get a negative 25 or positive 25. That's also not going to work. These numbers, when I subtract them, I'm going to get a 15 or a negative 15. Not going to work. Now, these ones will work. When subtracting them properly, I want to get a 3. So I'm going to have to do 9 minus 6 to give me this 3. So I'm going to do a positive 9 minus a 6 to give me 3. And then we can just place these in here, 9n and negative 6n. Now we look for the dimensions. Common factor between these two is n. Common factor here is n. N multiplies with a 9 to make 9n and a negative 6 to make negative 6n, and then just checking the last box that it works as well. So your factors in either order, n minus 6 and n plus 9. Okay, go ahead and try question 20. Again, write out your factors in 2 sets of parentheses. Okay, question 21. First term in the first box. Last term in the last box. Let me actually move that down because I'm going to make some space for my factors. There we go. Okay. So we've got v squared, we've got 16, and then we're going to multiply those. That goes to the top of the diamond. Negative 10v goes to the bottom. Now I'm looking for numbers that multiply to 16. So 1 and 16, 2 and 8, 3 doesn't go in, 4 and 4 times 4 does. And that is it. No other numbers multiply to make 16 that are whole numbers. So now I say, okay, I'm multiplying to make a positive, but I'm adding to make a negative. The only way to multiply and make positive is with 2 positives, but then they won't add to negative. So I need to make these both negative. Negative times a negative will give me positive. So then I can go up to all of these and say, okay, well, let's make all these negatives. And now which of these adds up to the 10? And it would be 8 and 2. So negative 2v and negative 8v. And we put these into the box in either order. Okay, so common factor here is a v. Common factor here is v. V times a negative 8 is negative 8v. V times negative 2 is negative 2v. And then the last parts multiply out properly. And I ran out of space for my factors, so I'm just going to write v minus 2. That would be one factor. V minus 8 would be the other factor in either order. Okay, go ahead and solve question 22. Write out your 2 factors. Okay, and our last question. First term in the first box and a last term in the last box. Okay, so we're multiplying 5 and 18. 5x squared and 18, so that's 90x squared. Middle term's 33. That goes to the bottom. We're going to go ahead and find factors of 90. So 1 and 90, 2 and 45, 3 and 10. 4 doesn't go in, 5 does go in. Let's see, 90 divided by 5 is going to be 5 and 18. 9 and 10 also works. And I think those are all my factors. And you don't have to write all these out. It's just a habit that I've gotten into. So now I'm looking for numbers that multiply to a positive. Okay, good. So these both need to be positive because they're also adding to a positive. And we also need the numbers to add to 33. So I'm looking at my list here. Oh, guess what? I didn't have all my factors down. What's other numbers? Let's see, 9 and 10, because none of these add to 33. So we got to find some more factors. 90 divided by 20. Oops, that doesn't work. Oh, hello, 30 and 3. Oh, that's because I wrote 3 and 10 here. I was wondering, I was like, there's got to be other factors. 3 and 30. Keeping me on my toes here. Okay. So 3 and 30 adds to 33. So I'm going to put 3x here. Hopefully you were like, Miss Reese, you're going to figure this out in a second. And we'll put 30 there. Yeah, sorry, this was not a 10. 3 times 10 is not 90. So now I can properly fill in the rest of my box here, 30x and 3x. And then I'm looking for common factors between these two terms here. So 5 and 3 don't have a common factor, but the x's do. And then common factor between these two would be 5. 5 goes into 5 and it also goes into 30. And they also have an x in common. Okay, now 5 times 6 gives me 30x. And x times a 3 gives me 3x. And then 3 times 8 is 18. So now my two factors are going to be x plus 6 multiplied with a 5x plus 3.